Properties of logarithms. Now, the previous section, we simplified logs using some of those special little rules. Properties of logarithms help us simplify more complicated logarithms so that we can use those little rules and those little strategies. So, there's three properties. There's something called the, there's something called the product rule. There's something called the quotient rule. And then there's something called the power rule. Now, all three of these rules, they take a, take a complicated log and break it down into smaller pieces. Now, we just got to remember what the properties say. Okay, let's look at the product rule first. The product rule has to do with multiplication and addition. Alright, here's what the product rule says. If you have a log of two different things multiplied together, you can split that into two pieces. I can take the log of the first piece, put a plus sign, take the log of the second piece. This will allow us to simplify complicated logarithms. Here's an example of what I mean. Suppose I had log base 3 of 9x. Now I can't simplify that as it's written, but we can use this product rule to break this apart and take the log of each piece separately. I get this. Now, what you're supposed to do, since my base is a number and this is a number, we have to try to simplify that if we can. Now, this comes back to the other section. The logarithm is an exponent. So what exponent of 3 gives me 9? And the answer would be 2. I can't simplify this one because it's an x. So what I end up with is this as the final answer. Suppose I had, I don't know, let's do log of 100 xy. Now, notice there's 3 pieces. That means I'm going to have 3 logarithms. I'll take the log of the 10, put a plus sign, take the log of the x, and put a plus sign, and put the log of the y. Now, because this is a number, we have to try to simplify that. So we got to remember what kind of logarithm this is. This is the common log, and remember the common log. What? That should be 100. Sorry, that should be 100, not 100. You know, our base is understood to be a 10, so we're trying to find the exponent for 10 that would give me 100. That would be 2. Then we put a plus log of x plus log of y. This would be the only thing I can do. Now let's do another one. Let's do log of base 4 64x. So it's multiplication, so we split it apart. Log base 4, 64 plus log base 4 of x. Try to simplify this one if you can. And what power do I raise 4 to get 64? And that answer is 3. Then we've got plus log base 4 of x. That's my answer. Alright. Natural logs. Let's say I have the natural log of EX. So it's multiplication. Take the natural log of the E, put a plus sign, take the natural log of the X, split it apart. Just to make sure that you're seeing what I'm doing. I'll highlight. I should have highlighted the other ones, but let's just, the X is here and the X is here. Now, let's go simplify. This is that special property that says ln E is equal to 1. Then we've got a plus natural log of X. Alright. So we're trying to break it apart into smaller pieces and simplify. Now, let's look at the quotient rule. Quotient has to do with a fraction and subtraction. So quotient is going to be fraction and subtraction. Here's what the quotient rule says. If you have a fraction, you can break this apart as a subtraction problem. You take the log of the numerator, you put a subtraction sign, and you take the log of the denominator. Now, you can think of this as a subtraction symbol, right? It's a fraction, so it turns into subtraction. Alright, so let's say I had log base 7 of x over 49. So we're dividing, and I can't simplify it the way it's written. So we're going to break it apart. The x goes first, then the minus sign, then the 49. Whenever you have a number for your base and a number where the 49 is, you have to try to simplify it. So as long as everything is numbers, you can try to simplify it. Well, that's a 7. 7 to the second power equals 49. So this is the final answer. Alright, let's say we had log of 5, 125 over 7. Why not? So again, break it apart. Put the top first. Put the minus sign. Put log 5 and put the bottom. Now again, let's try to simplify this. 5 to what power equals 125? Well, 5 cubed gives me 125. Now, this one, there's no relationship between the 5 and the 7. So I just have to rewrite it. I can't do anything with it. I can't turn it into a decimal. I can't do anything. I want to leave it just like this. That's the final answer. Alright, suppose I had natural log of 15e. So it's a fraction. Break it apart. 15 goes first, and the e goes second. I can't do anything with the natural log of 15, so just rewrite it. But I can simplify ln e. Ln e is 1. This is the final answer. Now, let me explain this so you don't get confused. I can't subtract a 1 from the 15 because the 15 is attached to the natural log. they go together. So that has to be the final answer. What I've got squared off. So this is definitely the final. Cannot subtract. I guess if you want to subtract, you'll get the wrong answers. I guess that's up to you. But try to remember you can't subtract when there's a natural log of a number and just a whole number. All right. Let's do the power rule. The power rule is the easiest one. Power deals with exponents. Here is the power rule. If you have a log of anything with an exponent, I'm going to put N for the, no, I'm going to put P for power. If you have an exponent, the rule says you can put that exponent in front of the log and you don't have it any longer. So the power goes in front. Here's a simple example of that. Let's say we had log base 3 of x to the 12th. I can take the 12, put it in front, and that'd be my answer. In this case, that's just the answer. We're just moving the exponent. If I had, let's say I had ln of e to the 9th. According to the power rule, I can take that 9, put it in front of the ln e. Now guess what? This is that special property again. ln e is always 1, so this is really 9 times 1, which is 9. So the power rule helps us simplify things. Now, we want to be able to take these rules and combine them into one problem. So let's say I had log base 5 of x to the 3rd times y to the 4th. Now notice there's an x times a y. Now, this is multiplication. So we're going to have a plus sign in between two logarithms. X cubed, and put log base 5 of y to the 4th. Since they have exponents, we have to turn around and do the power rule. So this has two rules I have to use. So we'll have 3 log base 5 of x plus 4 log base 5 of y. Now, let's say I had log of x to the 4th square root of y. Okay, let me kind of explain this a little bit. When we're dealing with logarithms and we have a square root, we must convert that to an exponent. Square roots are represented by a 1/2. If I had a 5th root, that would be represented by a 1/5. So we must convert them to exponents in order to apply these rules. So let's take this one. Let's take, oops. Yeah. Oh, shoot. So let's take this and let's break it apart. So we're going to have log x to the 4th plus log square root of y change that square root into an exponent. Then we apply the power rule. What I get at the end is the final answer. So anytime you got a cube, you have to convert that into an exponent. Then you can do the power rule and everything you have to do with that. Now, let's do a few more of those, and then there's a certain order you're supposed to do these in. But let me just show. Let me just go ahead and do it. So what this is called is called expanding logarithms. To expand logarithms, you do the following. You do the quotient rule first. Second thing you look for is product rule. And the third thing you look for is the power rule. So the ones I was just doing, I was doing expanding logarithms. Expanding means creating multiple logarithms out of one. All right. Now, let's do log of 7 over 49x squared y cubed. Now, this is a fraction, which means it's a quotient. So we're going to do the quotient rule first. Put the numerator, everything in the numerator, minus the log base 7 of what's in the denominator. Once you do the quotient rule, you're going to check each piece to see if you could do the power rule. Well, notice this one has two pieces, a 49 and an x squared. So we can break this piece apart and we get this. The next step is to do the power rule and simplify if we can. Well, notice this is all numbers. So let's try to simplify that. What exponent for 7 gives me 49? Well, that would be 2. For the second log, we put the exponent down in front. And then for the third log, we move the exponent down in front. And we get this. This is the final answer. Let's do let's try let's do this. Let's say I had log of, we'll just do base B of x plus 1 over, I don't know, 15. Why not? Well, it's a quotient rule. We're going to break it apart. The numerator goes first, minus the denominator. Now, I can't do anything else on this problem. I just wanted to show you one where it doesn't have to have a single variable. It's got a binomial. But that's all I can do in that problem. Alright, let's see. Let's do a couple more just for the heck of it. Let's do log base 4 of square root of x y cubed over 64. Now, it's going to be a subtraction because of the quotient. So we do quotient first, break it apart, log base 4 of the numerator minus log base 4 of the denominator. check them to see if you could do the product rule. Well, notice here, this is a product, x times y. So we can break this one down one more time. That's square root of x. Whoops, not like that. Plus log base 4 of y cubed minus log base 4 of 64. Now, I'm going to go simplify and do exponents. Okay, yeah, I just did this one a minute ago. That's an exponent of 1/2, right? So we're going to have 1/2 in front of that. We're going to have 3 in front of this one. Now, this is all numbers, so we need to try to simplify that. Is there an exponent I can put on 4 that will give me 64? And the answer is yes. It's 3. So this, sorry, let me erase it. This is the final answer. So you've got to do them in a specific order. Quotient first, then product, then power. Now, let's do what we call condensing logarithms. Condensing logs is doing everything I just did in reverse. It's taking multiple logarithms and creating one log at the very, very end. Now, you have to do these in a specific order. You do the power rule first. Then you do the product rule. Then you do the quotient rule. I'll do some simple ones and show you what's happening. Alright. Let's take some, let's say I had 4 log base 7 of x. And my instructions say to condense. Condense means if there's a number in front of the log, reattach it to whatever you have, a variable or whatever. So put the 4 in front, in this case back as the exponent. That is condensed. That's what it means to condense. So let's say I had 1/2 log of 17. Well, that 1/2 is my exponent, so we put it, move the exponent, and attach it back to the 17. And you might want to go ahead and do this, change that back into a square root. So when you've got a number in front and it says condense, you put it back as the exponent. Let's say I had log base 3 of x plus log base 3 of, I don't know, y, I guess. My instructions say to condense. Now, my answer will be a log base 3 and a set of parentheses and something in the parentheses. This is a plus sign. Inside the parentheses will be multiplication because that's the product rule. If it's multiplication, we split it apart as addition. If it's addition, we put it back together with a multiplication. So this is going to be x times y. Converting it from a plus back into a single log. Let's say I had, let's do this. Suppose I had log of x plus log of y plus log of 13. There's 2 plus signs. So this is multiplication. We're going to have 1 log at the end multiplication. I'll put two multiplication symbols. Multiplication, multiplication. X, the Y, and the 13. This is the answer. Or you can rewrite it like this. 13xy.
Are you videoing?
Yes. Let's do a quotient rule. All right. So the subtraction means fraction. So we're going to have a 1 log, parentheses, and a fraction. The 17 is first, so it goes in the numerator. The x is second, it goes in the denominator. That's my answer. So I had 3 ln 7, whoops, minus 7 ln x. Now, because there's numbers in front, we have to do the power rule first. So we're going to have put the 3 back with the 7, put the 7 back with the x. Alright. It's a subtraction, so now we're going to turn this back into a division problem. The 7 cubed goes first in the top, the bottom is the x to the 7. This is the final answer. Let's do one where you got to do all 3. How about we'll do 1/3 log of x plus 5 log of y minus, whoops, minus, I don't know, 7 log of z. That is not a z, y'all. Z. They all have numbers in front, so we're going to apply the power rule before we do anything else. So we're going to get log of x 1/3 equals log of y to the 5th minus log of z to the 7th. Once you do the power rule, you're going to look for the product rule. Well, notice here's a plus sign. We can take these two logs, squeeze them back together as one single logarithm, oops, times y to the 5th. There is a multiplication here, not an addition sign. That wouldn't make any sense. Then we've got minus log of z base 7. Now notice there's a minus sign. So this is going to be a fraction. X to the 1/3, y to the 5th over z to the 7th. You've just got to take your time on this. Now, I want to show you a rule that will allow you to evaluate any logarithm using your calculator. This is called a change of base property. We can take any logarithm with any base and convert it into something I can use a calculator for. Now, let me show you what I'm talking about. Suppose, well, here's what. Suppose I have log base 3 of 15. There is a rule that says I can take this logarithm, convert it into 2 different logs divided by each other. Now, notice that this base is 3. As long as I do it to the top and the bottom, I can change my base to be anything. Let's say I want to change it to a 17. Why? I don't know. Just to show you what's going on. Alright. The 15 goes in the top. The original base goes in the bottom. So I took one log and I created a fraction. In the top I put log, in the bottom I put log. I chose a different base than what we started with, which is the 17. And I put the 15 up top and the original base in the bottom. Now, this is the same thing. Suppose I wanted to do, let's say I did my base was 101. I could make it be this. Here's the original base, and my new base is now 101. Why 101? I don't know. Just because I didn't have anything else to do, I guess. So, the base can be anything. The base can be changed. Now, if I can change the base to anything, that means I could use my calculator. Now, what we're going to do is we're going to use natural logs. Let's say I had log base 15 of 107. What I can do is I can put an ln up top and an ln in the bottom. The original base goes in the bottom. The other number goes in the top. So for any log that I can't do the calculator on, we can use this special property to use the calculator. Now, if you wanted to use your calculator on this, you would hit your ln button, enter the 107, and do a close parentheses. Then hit the division symbol. I don't know if it's a, I'll just do that. Then hit your ln button and enter the 15, close your parentheses, then hit the enter symbol. Then hit enter or equal. If you've got the TI-30X2S, this is the steps. If you got the other one, I'm not sure. I'd have to look at that and see. I think you enter the 107 first, then hit natural log, then hit the division key, then hit 15 ln, and then hit the equal sign. I'll have to look at that and see. Now, so let me just rewrite a few more. Suppose I had, I don't know, log of 37. So we put ln up top, ln in the bottom. Now remember, the base goes in the bottom. This base will be a 10 because this is understood to be a 10 writing. The 37 will go up top. Let's say I had, I don't know, ln, well, I can do ln on the calculator. Let's say I had log of 1047 of 3. Well, ln up top, ln in the bottom. The original base goes in the bottom. Hey, that's a good idea. Base in the bottom. Base in the bottom. And then the 3 would go up top. So this is a shortcut, not really a shortcut, it's a way to do logarithms on the calculator by doing this special property. Now, work on the homework. If you got any questions, email me, Zoom me, whatever. But you'll have plenty of time to do this.